right, here we go. Compound interest. So these are going to go kind of quickly, so bear with me. So for compound interest, it's a formula, right? And essentially with this formula, you are calculating the amount of money or amount of people or amount of anything that has grown over a period of time. All right. It's already written at the top of your paper, by the way, the formula. Yeah. So your A is your amount, your principal is your P, which was just our A, right? Our P is just our A. Okay. Our middle, this is our growth factor, right? Our growth factor is breaking apart between your rate divided by the number of times the interest is compounded per year. Okay. So the number of times that it happens over the course of the year. All right. And then time is years. So T is for years. It's always years, 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 years. Okay. So if I give it into you months, you have to interpret, you have to not translate. You have to convert those months into years, like how much of a year is that, okay? But it's always in years for compound interest formula. All right, now, how did this formula come into play? Well, this formula came into play because someone realized, okay, we have our regular interest formula where we are growing or decaying, right? Our regular growth, which is the y equals a times b to the x, correct? We have that. And what happens though if it's doing it every single month? Like I don't want to have to keep doing it every single month. Or if it's compounded every 3 months or compounded, well, that's the word. If it happens over and over instead of me just doing it one time, is there a rule to follow? And that's what someone came up with. So we're going to start off here and build up to that. Imagine you want to buy a computer, a really nice computer, but it's $1,500, right? You're like, ooh, I don't really have that kind of money. But the computer superstore says, it's all right. We have credit card options for you. And you can get the computer of your dreams just today, right now. Okay. So these are the options that the credit card company, the store offers. Okay. You have option one, interest charged at 24% annually. Option two, interest charged at 6% quarterly. Option three, interest charged at 2% monthly. Okay. Without discussing with anyone or me, which option would you choose? Write it down, commit to it, put your reason. It's not a right or wrong situation. Well, there is, but right now it's your opinion. Based on what you know and what you feel, which option would you take in order to get that computer of your dream? Would you take option one, option two, or option three? That's the first part you're writing down. So right here, so this is where make a choice. All right. So you're either writing down option one because dot dot dot, option two because dot dot dot. All right. What are some strategies you might use to find out for sure? Well, we could make a table, right? We could guess and check, or we can use what we already know, which is use our y equals a times b to the x, right? Because that's something we already know. And if I use that, then I can calculate my information, right? When this happens, this is called compounding. Okay. When your interest accumulates, it's called compounding. Okay. All right. So, yes, I realize that sometimes my cursive tries to sneak out and I just end up merging it all together. All right. Are we ready to use our knowledge and figure out if you were right or wrong? Just by show of hands, how many people said option one? Okay. Okay. Option two. Option three. All right. Here we go to the races. Okay. So you should have this chart on your next page. So on the chart, it says there's 24% annually, and you're starting off with 1,500. Well, we already know how to write our exponential model, right? When we're given our A and we can calculate our B, correct? So remember our A is our what value? Our initial. So our A is always our initial. So A equals your initial. And your B is always your value that is either 1 plus or minus that percent, right? Do y'all remember that? Yes. Okay, so for our first one here, it says that this is our annually, and we have our value. So in this box, we would be writing our exponential model that represents that. I don't have enough room to write it in the box, so I'm just going to put a circle so that I can write it over here, and you know that that circle is what goes in that box. Does that make sense? Because it's too tiny for me to try to write, and I'm not even going to do it, okay? So in the box, I would write my initial, I have y equals, what's my initial value? 1,500. My B is 1 plus because it's interest, so it's going up, right? And what is my percent? 24.24, right? Did I write that correct? Yes? Okay. Now, part that matters here, it says annually, which means that this is only going to happen one time, right? So the rest of this does not matter because it's only going to happen how many times? One time. So over the course of the year, all I need to figure out is after one go, how much is it going to be? So I'm looking for when my x equals 1, what's going to happen? So I got to find that value. To find that value, all I'm doing is let x equal 1, and I will have that value. Does that make sense? Okay, so I'm going to pull up Sylvie because it's just easier to pull her up in this situation. Could you pull up whatever calculator you want? Yes. Okay, so I'm going to type in 1,500 times 1.24 to the 1, just for the sake of writing it. And what do I get? 1,860, right? So if I chose option 1, all in all, my $1,500 computer is now going to cost me $1,860. Make sense? That's credit card life. Be careful with it. Okay. All right. Do we feel good about annually? We see how that worked? That's what we've been doing, right? Okay. So I'm going to write 1,860, correct? All right. Now we're going to go on to the other one. The other one is quarterly. Okay. So we have 6% quarterly. 1,500 is still our initial. So again, Miss Jones doesn't have enough room to write in her. So this is going to be my square. So square is going to equal y equals 1,500, 1, and what's my percent? 6, so 0.06 to the x. Agree? Initial and my percent change, correct? All right, the difference here is that it's going to happen quarterly. Quarterly in over a year means that it's going to happen every 3 months. Does that make sense? So the key word here is quarterly. So every 3 months is what I'm calculating. So we would have 1, 2, 3, 4. Does that make sense? So at these intervals is where I'm going to be charged my interest because it's happened quarterly. It's happening 4 times in 1 year. Yes? Still with me? Okay, so this time, when you're finding this value, this is when your x equals 1. This is when your x equals 2. This is when your x equals 3. And this is when your x equals 4, because that makes up the entire year of that quarterly. Okay? When I have more than one value, it's a better idea to make a function and look at the table. Yes, we agree? All right, so I'm going to make a function and look at the table. So I'm going to open up Sylvie here, turn her on. I don't know what's there. She has a lot going on. So I'm going to just clear out. So I'm going to go to y equals, and I'm going to type in my 1,500. If you're using Desmos, you would type in your 1,500, y equals 1,500. If you do not put y equals or f of x, it won't let you pull up a table, okay? So make sure when you're putting a function into Desmos, you're either using y equals or f of x, okay? And we're going to type it in. I'm going to go ahead and add. I can add $1 plus 6 cents to the x. And now I'm going to hit second graph to pull up my table. So after my first month, it's going to be how much now? First month is $15.90. Second month is do we see it? Everyone sees the value for our four values? Yeah. All right. So I'm going to close mine. You're going to have to tell me them because I won't have it in my face. Is that cool? All right. So I'm going to minimize. So after 3 months, how much do I now own this computer? What is it? 1,590. After 6 months, now how much is my computer? Remember, it's only the two. You're looking at the 1, the 2, the 3, and the 4 because that's it being compounded. So when x equal 2, what is my value? How much? Do I need to pull mine back up? Thank you. 1,685. Okay. After 9 months, which is when x equals 3, how much is it? 1,786. And finally, after a year, how much is my computer now worth? 1,893. I don't know how you got to 3,000, but no. Okay, let's look at it again, making sure you put it in correct. So I put in y equals 1,500, 1.06 to the x, right? And then I hit second graph and looked at my table. My initial was 1,500. My first compound was 1,590. Second would be the 1,685. Third, and then my fourth. Okay, makes sense? That's what takes place in that year 1. Okay, that's how that works. All right, now we have the last one. The last one here, we are making a triangle because I can't write in that space. So triangle equals, our initial is, what's our initial? Did it change? 1,500. Still 1,500. I personally would never spend that much on a computer, but do you, boo? All right, and then its interest is pocket change. 0.02, right? Because it's 2% to the x. Do we see that? Okay. Now, the thing here is that this one is compounded monthly. So every month you're being charged interest on that computer. Okay. So because it's every month, that means every single month you're getting a bill with a new amount every month. It's going up, 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 all the way into the end. So this time, each one of these is an x. This is x equals 1, x equals 2, x equals 3, x equals 4, because you're being charged interest 12 times a year. Does that make sense? So you're being charged that interest 12 times a year. All right, so our model ends up being that. Now, I'm going to be honest with y'all. I'm not going to write all these numbers out. I'm just going to show you the screen with them because I'm not about to write them all out. So if you look up here, you'll see the values. So after the first month, I owe $30 now, right? Extra $30. Second month, an extra $60. Third month, an extra $91. And it keeps going and going and going. And by the time it's all said and done, for that 2% monthly, how much do I owe? $1,902.36. Okay? So once it's said and done, now wrapping it up, you're going to answer, were you right or wrong about which option you chose being the better option. And what do you think made the biggest difference? Was it the percent or the amount of times you were charged interest? Okay. You were right. No. It wouldn't. Annually, it's just saying that over whatever time window your contract starts, you're only going to get charged interest once a year. So whatever that balance is, that's what the interest is going to be. And then quarterly, it's like, okay, whatever your balance is after 3 months, we now charge you interest on it. Whatever your balance is after next 3 months, we now charge you interest on it. So it's the situational piece would be your initial, but the process would be the thing. Yep. All right. So do we see the dangers of credit card and paying attention to what rates we're getting? Yes. And how it's being charged? Yes. This is like kind of like just the baseline of it. All right. So 5 and 6 is on your own. It's just a little quick. Now we're gonna actually use the formula on the back. So we're gonna do a practice problems using the formula. Got it? All right. So obviously, you should choose the annual one. Only have them charge you interest one time and one time only, or 0% interest for the first year. So you can pay it off and not have anything charged. Okay. I'm not ever telling you to get a credit card. I understand. But all right, so let's use this formula. Okay. So instead of you having to do those charts over and over, guess what someone did? They made a formula for us, right? So now, instead of us trying to think, okay, every 3 months this is happening, every 4 months this is happening, the formula was created saying, okay, if it says that you are being charged a certain amount of time, that's what that in value now represents. That in is now going to tell you after a year or after 2 years how much you're being charged or earning, either way. Okay, that's your compound value. If it's annually, obviously n equals 1, right? If it's quarterly, how many times did I get charged in 1 year when it was quarterly? Yeah, how many times though? At 6%, we had 4. So our n would equal 4. Does that make sense? Okay. If it's biannually, then it would be 2. Does that make sense? With me? All right. So let's do a problem using the formula. I personally like formulas because they make life easier. So up here we have Pierre invests 1,000 in an account that earns 15% interest compounded quarterly. Okay. Suppose that he makes no deposits and no withdrawals. Write an exponential function that you could use to determine the amount balance after T years, then use it to determine the account balance after 10 years. Okay. So the formula that we're using is our A of T equals our principal times 1 plus our R over our N to the NT. All we have to do is identify each part. What's our A? What's our P? What's our N? Okay. So step 1 is to find your variables. State your variables. Okay. So the first thing we're going to do is find our variables. What is our A? Which is our P, which equals what? 1,000. With me? Next is our R. What is our R? And so it's going to be 0.15. Your N is how many times are you being compounded? Compounded how many times? 4, because it said quarterly, right? Compounded quarterly. Okay. Step 2 is to substitute everything in. So now we're going to substitute everything in. So we have A of T equals 1,000 times 1 plus 0.15 divided by 4 to the 4t. You see, I just plugged everything in to where it goes. That's the beauty of a formula. Okay. After you do that, your only job is to simplify the middle. Okay. Am I going to make you do this in your head? No, you have a calculator. What is 1 plus 0.15 divided by 4? Type it in. So we have A of T equals 1,000. And we're going to type in, enter our handy dandy calculator. Here's old girl Sylvie. So we have 1 plus 1,500 divided by 4. And our growth factor is 1 in 375 to the 4t. And that is your model. Okay, how do you feel about the model? Or finding it? Good. All right. Now, after you have it, you can find out whatever it's asking you. So it asks us for how much money will we have made in 3 years, right? So now we can solve. You just use the forward slash button and it'll turn it into a fraction. You'll type the numerator and then forward slash. Got it? All right. So what amount are we looking for? 10. So we're looking for A of 10, which equals 1,000 times 1.0375 to the 4 times the 10. And I plug that into the calculator. So I'm going to go to Sylvie because she's just easier for you to see while my screen is up. I have nothing against Desmos, I would like to point out. It's just inconvenience to demonstrate both. I know 4 times 10 is 40, but so you can see, and no one asked me, Miss, where'd 40 come from? I wrote the 4 times 10. Okay? And so, how much money is in my account now after 10 years? $4,360.38. That is compound interest. Ask your questions, comments, concerns, because at this point, the next practice is on you. So, yes. I put 40 times 10. Yep. I wrote exactly what I wrote on my paper is exactly what I typed in the calculator. Or you could just write 40. 4 times 10 is 40. You could just write 40, or you can write 4 times 10. Okay? All right. Talk to me. Questions, comments, concerns? All right. Yes. Where did you take the part? Like the A of P equals 1,000. This part? Yeah. All I did was simplify the middle. Remember 1 plus 0.15 divided by 4? And that gave my simplified growth factor. I literally typed that in the calculator. 1 plus 0.15 divided